We've talked a lot about building things on this channel, building projects, going from conceptualization where you have this great idea all the way to when you're actually mapping out the features that you want and turning them into code. Building and conceptualizing and then finally being able to map that to actual code is a really important skill, and I think we've talked about it enough. Today, I want to talk about a topic that I think is a little bit underrated when it comes to talking about and measuring developer or engineer skill, and that's debugging. How good are you at debugging? I think you should get better. I think I should get better. I think everybody should get better at debugging, and I'm going to tell you why. We're going to talk about why I think you should get better at debugging, how to get better at debugging, how I think about debugging, measuring skill and stuff like that, and what I really want to hear, because I think this could be a really sick discussion, because no two minds are alike, and I'm going to go over my process when I'm debugging and how I think about these sorts of things. I want to hear it from you. I want to hear how you go through the process of debugging, what your thought process is, so that we can all kind of like accumulate and be like a little hive mind where we all just accumulate each other's knowledge and skills and stuff. Because I think this particular topic would be a really interesting discussion. So debugging. How do you get good, or how do you even measure how good somebody is in the first place? So here's the thing. For me, personally, at this point in my career, and my sort of thought process, and I'm curious to see how this changes. For me, it all comes down to context. So what is context? Context is stuff that you load into your head about how your program is executing while it's executing, or even you sort of step through the execution of your program when it's not even running, and you think about, well, this is where it would be up to. This is the flow of my data through the program as it's running. Like, if I do this input, this function gets called, or this callback is run, or user input is handled in this particular way. Things like that. Or if you've got multiple threads, you're thinking, this is the state of my thread synchronization at this time, right? So like thread 1 is waiting, thread 2 is doing an operation, and then thread 2 yields and gives data to thread 1, things like this. Or if you've got a microservice or an event-driven system, you know, this guy sends out an event, who's consuming that? And at what point in time is that consumed? So context is all about how accurately can you model your program or system in your head while you're thinking about, you know, how it's running. And if it's not immediately obvious how that's helpful for debugging, maybe listen a bit more, because I think I'll expand upon it, and I hope you'll agree. So when I measure how good I am at debugging, and I look back over the years and I'm like, this is how good I am at debugging, I sort of measure it in two ways, and they both relate to context. So first off, the first unit of measurement is how much context can I hold in my head at one point in time before my brain starts to hurt. So this thing, capacity of context, right? I might refer to it as that, sort of caps the complexity of the systems that you're able to debug. So if I am able to load a lot of context into my head, theoretically, I can debug a very high level of complex systems, if that makes sense, right? The more moving parts a system has, the more context I would possibly need to load into my head in order to figure out what's going wrong with it or why something's breaking. The second thing, but this alone is not good enough, right? Because you can load in a whole lot of context, but if it's all incorrect, that doesn't actually mean anything. So the second thing I want to mention is accuracy of context. So the two things are capacity of context and accuracy of context. So accuracy of context is essentially, I'm trying to model out my program's execution at this current point in time where my undefined behavior or bad behavior is occurring. How accurately am I able to build up that model in my mind, right? Like, am I able to accurately pinpoint where my program is in its execution? Like, which function is getting called? Where is this data being stored? What kind of transformations are happening? What is the state of my application at this point in time when the problem is occurring? And that's sort of an intuition thing, right? Like, you notice the behavior and you notice the context around it. Like, this is the behavior. It happens when I do this. And then you sort of build up that model and you think, okay, these are the functions that are getting called. This is the event that's happening. This is the state of my threads at this current point in time. So you're thinking about where your program is at, and the accuracy is how well you can pinpoint that. And the context, of course, is just how much. So thinking about it like that kind of way, right? If I'm starting to debug a system, the two things I'm looking out for are immediately my intuition goes, where is this happening in my system? So I start loading in the context about where I think that problem is occurring. And the amount of context that I can hold is, of course, going to cap the complexity of the system that I can debug. So those are my two metrics, right? Capacity and accuracy. I'm going to give you a sort of real world example of something that I had to debug recently and we're going to measure it in terms of those things, and we'll see how impressive it was. So at work, we are using C# to build some internal tools. Now, these internal tools talk to devices over Bluetooth. So Bluetooth Low Energy. I can't tell you all the nitty-gritty details because I'm under NDA, but I can tell you sort of the boilerplate, publicly released stuff. So our devices at work communicate over Bluetooth. We're building an internal tool in C# that we want to use to, update software, change some configs, things like that. And so we had initially done this with the Windows Bluetooth APIs, but we found them to be quite unreliable. So the Windows Bluetooth APIs don't give you the full amount of control that we want in order to do some of the things that we're doing. And so we're looking at switching from using the Windows Bluetooth. This is all relevant, I swear. Switching from using the Windows Bluetooth APIs to communicate with our devices to using this little USB NRF dongle. And what this does is essentially it's a COM port, so you can talk to it over USB serial, and you can tell it to do all sorts of things like, give me a GATT server, give me a GATT client, give me this, give me that, blah, 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 blah. And Nordic released a sort of API driver thing that you can use in your applications to talk to it, which is great. So at the moment, we've got a couple of things in our system, right? We've got an end device that is connected over Bluetooth. We've got a C# application that has a whole bunch of logic behind it. And we've got a communication stack with this Nordic Bluetooth thing. So here's the deal. The Nordic Bluetooth stuff is written in C. And my initial thought was like, okay, our tool is in C#, we've got this driver in C, it's just a serial port, right? Let me do a port. I'll port the code from C to C#. It was way too complex for that. So what I ended up having to do was using interoperability, which is essentially, if you've got code in two different programming languages, interop is where your code in one language, typically a higher level language, is able to call code in a second language, typically a lower level language. So in this case, I split off the NRF library into a DLL, made some wrappers to make it a bit nicer for C# to deal with, and imported that into C# and used interop. So our system is getting quite complex, right? We have an end device over Bluetooth that's an embedded device. We've got a C# program that has all of the sort of business logic for doing what we want to do. We've got a serial port communication with this NRF dongle that's called with interop on some like API that Nordic has written a driver with. And what we're doing is doing like firmware updates. So we're streaming in a file over Bluetooth. And one of the things I noticed, once I rewired our program to use this NRF dongle, is like, okay, I'm sending off a couple of chunks and I'm getting a CRC back, but my CRC check is failing. So that means my file was not received correctly. Why is that the case? Let's think about this in terms of our metrics, right? So in terms of capacity of context, I'm able to load in all of this stuff about my system. We have multiple threads. Oh, I forgot to mention the Nordic driver is all event-based, so it all runs on different threads. So I've got different threads in different programming languages. I've got synchronization between two different programming languages. I've got an event-driven architecture. I've got a serial COM port. I've got an embedded device. I've got file streaming. I have a lot of context in my head right now to sort of fix this problem. There's a lot of places where this code could go wrong. And so that's the capacity of the context, right? I can model a complex system in my head like that. And I'm thinking about, well, at this point in time, it could be a synchro issue where I'm getting a CRC or notification back, and maybe I'm not replying to that correctly, like it's requesting some part of this file and I'm not sending that back correctly, or there's a timeout issue or something like that. It could be a thread synchronization problem. It could be, I'm not sending the file in correctly. So there's an interop issue. Like when I'm passing my data buffer from C# to C, that is probably where there's going to be an issue, right? Like you'd think going from a high level managed code environment to a low level environment where, things aren't dynamically allocated and things like that. It's like there are lots of problem places where this could be an issue. So that's the capacity of context. And the accuracy of the context is like, okay, I've got this very complex system. Let me pinpoint where this problem actually is. How do we actually get better at this? So accuracy comes through intuition. And that is purely to do with frequency. So purely to do with the number of things that you debug. So the more you debug, the better your intuition is going to get. The complexity of systems, like how do you improve your capacity for this sort of thing, that comes from pushing your boundaries. So what do I mean by that? It's like if you are comfortably able to think about and model, I'm going to use as an example, an application with 2 threads. So we're looking at a single application and there are 2 threads and the threads are going to have to be synchronized. So if you're comfortably able to model that, like I can hold in my head, this is where my threads are up to in their execution at this current point in time, and this is what my data flow is like. Maybe you can introduce a second program over a network, right? So instead of now only having a single program with these 2 threads, when we've now got 2 sort of identical programs with multi-threading, and they're both going to have to be synced up. You're going to have to receive data over a network. So it's all about pushing your boundaries. It's like if you're comfortable debugging and loading context in about this kind of application with this level of complexity, just step it up a little bit. And you'll notice over time, the complexity of the systems that you're able to think about and model really it's like exponential growth. The more that you do this and the more that you model complex systems, it's actually insane. Like I look back at myself from a year ago, and I was making YouTube videos a year ago and things like that. And of course, I think I was pretty smart, but I look at myself now and I'm like, the me from a year ago would not have been able to model this interop thing that I was just talking about. Like, no way would he be able to do that. It's just from constantly pushing your boundaries, like the whole frog in boiling water thing, right? Like the frog doesn't notice if he's being boiled, like slowly boiled in water. You won't notice if you just incrementally step up the complexity. But if you take a step back and, sort of look down the mountain and you're like, wow, a year ago, I would not have been able to model a system like this. That's where you really start to think, okay, this is cool. I'm learning, I'm accelerating, I'm growing, and I can do even better than that. Like think about where you'll be in a year. Like this is where you are relative to yourself a year ago. This is the level of complexity and systems that you're able to map out and debug and interact with. Think about where you'll be in 1 more year if you just keep doing what you're doing. And that's sort of like my opinion on it, right? The 2 measurements that I have for debugging, like how good you are, your skill, a really underrated skill, I think, is complexity. So capacity, how much context can you load into your head about a complex system? And accuracy. How accurate are you able to pinpoint in your execution where this thing is actually going wrong? And essentially, like the end goal of that is your mind just goes like boom, 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 and you sort of like narrow it down to the final endpoint where you're like, okay, I've arrived where the bug is. I think this is the current state of my program. This is what my variables will look like. These are the function calls. This is where my issue is. And of course, there's a lot of trial and error as well. Like your first pick is, of course, never going to be correct. So those are my thoughts. I really want to hear from you guys what your process is about debugging. Let me know. Cheers.